All right. Let's say that we have three vectors, A, B, and C, that we're going to add together. And let's say that vector A has a length of 16 centimeters and at an angle of 28 degrees, let's say southwest. At. Like the at symbol in your email? At just means the directional you're about to give. Let's say the second vector, so we know that we start by going southwest. So the person's going to go this way to start. Let's make the next vector just north. So then the person moves, or the object moves 10 centimeters north. No angle, just north. And then after that, the third vector, give it a sec, it's delayed. Just give it a sec. Huh? Person travels north for 10 centimeters, or let's say it's an ant, right? An ant crawling. After the ant crawls 10 centimeters north, the ant then says, you know what? I smell some food somewhere else. I'm going to turn again. So the ant decides, instead of going, the beginning the ant went southwest, then north. Now we're going to say that the ant now goes northwest. So the ant then travels 12 centimeters at an angle of 42 degrees northwest. So, let's begin this problem by drawing a diagram of what we see. Go ahead and sketch what you think this looks like. A, then B, then C. I want it in that order. The order doesn't really matter because it's commutative, but draw what you think that represents. What is 16 centimeters at an angle of 28 degrees southwest? Just sketch it. Then sketch from there the ant going 10 centimeters north. Then sketch the ant's motion for 12 centimeters at an angle of 42 degrees northwest. Again, these are sketches. They're not exact. But they should be relatively close. For example, your 16 centimeter length should be longer than your 12 centimeter length. Okay, but you're not doing it exact because you don't have a ruler and a graph and a protractor. So literally, I want to see you guys drawing the direction you think this would move. Okay? Now, if we don't know what southwest is, we think, okay, here's west, here is south of west. So this is the angle right here that I'm showing, and this is the direction the ant will move in the beginning. Which way is south? Which way is west? Put them together. Southwest. West, south, put them together, southwest. So the beginning, I'll give you a hint. Here's the first one. We could put a little horizontal. Make sure you always have a horizontal in. Here's the first one right here. We want 28 degrees southwest. Here's the 28 degree angle. And the length of that vector is 16 centimeters. I'll zoom in on that in a moment. So again, what's 45 degrees? 45 degrees is halfway between 0 and 90. 28 degrees is going to be less than that. So this angle is clearly going to be a little bit less. It's not with the protractor, so I'm just estimating right now. Tom?
Oh, I was going to...
Good?
So you go straight back out to the horizontal?
Very good, Tom. And we might go past the horizontal. We don't know. It's an estimate, right? So we go north. How far? Okay, go north 10 centimeters. That's 10 centimeters right there. And then the last part, 12 centimeters, 42 degrees northwest. Aiden.
Just like this?
Yeah, very good. North is this. West is this. So northwest is going to be at an angle up to the left. 42 degrees pretty much splits it between 0 and 90. So if I'm going to go from here, now I have another horizontal. You have to kind of imagine these horizontals are there. And I'm going to have an angle of 42 degrees right here, and that's a length of 12 centimeters. So let me zoom in so you can see this a little bit better. I'm going to talk as I point. Yeah.
Why would we just use the same horizontal?
Because remember that the horizontal always occurs from where you start that vector. So where did vector C start? Vector C starts at the end of vector B, doesn't it? Right here? So you need another horizontal there. Because remember, the angle 42 degrees means it's 42 degrees above the horizontal. This is not the horizontal that intersects here. So every time you stop a vector and you start a new one, you have a new horizontal.
So why is there a horizontal under?
Here?
Yeah.
Because was there an angle given? It was only north, right? So we didn't need the horizontal there, okay? So we have, hold on, we have a starting point here. The ant moves at an angle of 28 degrees south of west. This would be west. This would be south. So 28 degrees below west. That's right here. That's the angle right there, 28 degrees. The ant goes for 16 centimeters. Then that ant takes a sharp turn and goes north. I don't need a horizontal with an angle because it's north. There's no angle involved. So just go directly north for 10 centimeters. Who knows where 10 centimeters really ends? Maybe it ends here. Maybe it ends here. Maybe it ends up here. It's a sketch. Then when you end segment B, you have a new horizontal right here. And then for segment C, the ant goes 12 centimeters at an angle of 42 degrees north of west. This is west. This is north of west. This is west. This is north of west. It is above that. Okay? Does that answer your question?
Well, I was just going to say that if you did use the same horizontal, and I get why you would.
It wouldn't work. Look, if you.
I know, but it would be the same angle.
No, it would not. Guys, if you try to connect your vector up here to the other horizontal, that's how big the angle is. It doesn't make sense. It has to connect. It has to touch. The end of this ray has to touch the horizontal. It doesn't, so you have to make a new horizontal. Do you get, though, the idea of a new horizontal? Okay. Shwan?
The 42 degree that's given. Okay. And also, would you say that if you add a horizontal, it seems like for what the pattern I see that like you add it when it's north and something else, like northeast, southeast.
You're always going to add a horizontal for everyone except for the ones that are either all vertical or all horizontal. So anytime it's northwest, northeast, any of those, you add a new horizontal. Okay, let's go back to the problem then. So, mind you, this is going to be a word problem. Like we had in the example on the notes from 3132, it would be a word problem. And you would have to go ahead and come up with your diagram based off of the word problem. I'm giving you the three vectors here. Okay, I'm telling you that this is what's happening to that ant. Now, remember what we did yesterday. To get the overall displacement from start to finish, we need to find all of the horizontal components. Can we shut the air off in the back, please? Whoever's near the back, thank you. We need to get all the horizontal components, and we need to get all the vertical components as well. It's in the closet right there behind you. And all the vertical components as well, and then sum those together. Okay, so our goal is going to be to add the horizontal and vertical components together to come up with the overall result, and that's so much better. It's cold in here and I'm young. It's cold. So let's go ahead and do that. Let's do what we did yesterday real quick. How do I find the horizontal component of a vector? What was the rule from yesterday? And it's just a matter of memorization. If you don't spend the time to practice, you're never going to memorize it. Lil, what's the rule?
Is it the cosine?
Yeah, very good. So if you want the horizontal component of this 16 centimeters, take 16 centimeters, multiply it by cosine 28. Now, is this object moving left or right to start? It's moving left. It's also moving down, but we're worried about left or right. Left is what in terms of negative or positive? Yeah, it's negative. So we're going to start with the following. I don't really need these numbers anymore. I have them all in my diagram. Here's what we're going to start with. In the x direction, negative 16 cosine. You don't need the parentheses around the cosine. I did that last class and it threw people off with their calculator. So I'm just not going to put it there for now. Times cosine of 28 degrees. Why is it negative? Why is it negative? What's the whole idea? When would it be positive?
When the displacement is going to the right.
Yeah. So since we're looking at the x direction, I don't care about up or down. All I care about is left or right. So vector A moved left, thus it is negative. Next, how about vector B? Which way does vector B move? Only up. Does it move left or right at all?
No.
So do we have to count it for the x direction?
No.
No. Vector C. Does vector C move left or right?
Right, it's negative.
It moves left. Look at vector C at the top.
That's right.
It moves to the left. So it is negative also. Also negative. Negative 12 times the cosine of its angle, which is 42. And we're going to sum those values together. Exactly. But since they're both negative, I can put a minus sign there, right? I'm adding two negatives, or I just put a minus sign. Same thing. Remember, you always add your components together to come up with the resultant component. How about in the y direction? Yeah.
You only add the components that have
Unless it's... We're going to use the north, but which way is north? Is that in the x or the y direction? North is in the y, isn't it? So the north part is going to come into play in the y direction only, because it's not at an angle. Anything at an angle shows up in the x and y direction. Anything that's either just north, or just west, or just east, or just south, only shows up in either the vertical or the horizontal, depending upon which way it is. Tom?
Then how come you only have an x?
I haven't done the y yet. I'm going to do the y now.
That's sine. You use y for sine.
Exactly. Very good. Okay? So right away, what Tom is noticing is this. The first part is going to definitely be sine 28. And it's going to be 16 still. Do we all see that? Because now we're just looking at the y component. But which way is that acting? Down or up? The first vector, down or up?
Down.
Down. So it's also going to have a negative sign. Again, vector A acts down and left. So because in the y direction it's acting down, we put a negative sign right here.
So it's like when it's in graph, like when you have a point in.
Yeah, you're literally locating like on an axis. What coordinate would this be? This would be negative, negative, right? Wouldn't they both be negatives? Negative, negative. That's where that comes from. Okay? How about the northwest? Or let's do the north part next. Vector B is 10 centimeters and it acts north, which is only the y direction, right? So there's no component needed. It's all in the y direction. So just put plus 10. I could put sine of 90 degrees, but sine of 90 degrees is 1, it turns out. So it doesn't affect the problem. There is no angle that's given here. It's only acting north, right? Vector B goes straight up, which is in the positive y direction only. This is positive 10, and it's only acting in the y direction. So I don't need an angle here. Yes?
If you did the horizontal line, you do the same thing.
But only in the... Absolutely. Okay? How about the last vector? How about the last vector? What would I write for that one? Vector C, Leckham. Which one? Does it go up or down? Goes up, so it's positive for that one. Look at the third vector. I'm going to point to it real quick, right up here. This vector moves really to the left, and it moves up. To the left is negative, but that negative was in the x direction, wasn't it? And when it goes up, isn't that positive in the y direction? So positive here, the 12 carries down, cosine becomes sine.
But tell about which thing they're trying to, because it's horizontal and it's horizontal and negative.
In the horizontal, it's negative. In the vertical, it's positive. So again, think about what Caroline said with the xy axis if you need to. If you consider this to be the new origin right here on an xy axis, this would be negative in the x, positive in the y. There's the negative in the x, there's the positive in the y. Okay? Negative in the x, positive in the y. Negative in the x, positive in the y. So as a result, we can come up with the answers for these. Go ahead and type this in your calculator in one line. Do the x in one line, do the y in one line.
Do you add them together and find them?
Because the other ones were negative, we subtract them. When it's a negative, you put a minus sign. When it's a positive, you put a plus sign.
Is the difference between this or just adding the sides together? Like if there's, say it says some, if I walk from there to there, oh, because you would see the triangle, and then it's just the triangle, and you add the two sides of the triangle together.
You never do that.
Yeah, you do.
You would do Pythagorean theorem in that case.
You're like, no, this.
Yeah, that's what we're doing in essence right now. Look at the second and the third picture and what you're looking at right now. See how the bottom of the triangle has different lengths, like 12.8 or something like that on the bottom? Yeah. No, the other one you just had it open a minute ago. Yeah. Look at the second and the third diagram. See the little legs of the triangles that are made, those little x values on the bottom of the graph, the second graph? Look at the bottom of the second graph. That's what we're doing. We're adding those x's together. That's x. And then we're adding the y's together also. Okay? I don't know
So
yet.
you never just add the sides. Never just do that.
Do you want us to round it?
10. Here's 10. Sam, what'd you get for the x? Negative 23? I think hers is probably right. I don't think yours is. For x. What'd you get for x?
I got 20.2.
20.2?
Oh, I got negative. I got negative.
I got
20.2 negative.
Is it?
I just cleared it.
No, you probably did it right.
Yeah, just literally
Oh, I think I might have put something in parentheses.
The answer is negative 23.04. Is that what you got?
Yeah.
Yeah, you're good.
now that's subtracting 12. The plus add 12 is 1 thing.
Guys, your math skills, your math skills need to get better. You need to practice, seriously. Because you need to know that when I write subtraction here, it's really adding the opposite. It's adding a negative. These are both negatives, and we're adding everything together. So I'm putting a minus here. It's the same thing as adding a negative. Okay? Y direction. And
I got 10.5.
others.
Yeah.
Nick?
I got 10.5.
Nick, you're not in the right mode. Hit mode. Hit mode. Is degree or radian highlighted?
I don't even know how I got it right here. I was on the tree yesterday.
It's fine. I mean, somebody borrowed it or you reset it, one or the other. When you reset it, it goes back to radian. Hit degree. Quit. Press second. Hit enter. It'll bring up your last line of code and you can redo it quicker.
Oh, that's good.
See what I'm saying or no?
Wait, what?
Press second. Press enter. It should re-show you what you did in the last line, right?
You have to get out.
Oh. Okay.
It'll bring up your last command. Redo it. See what you get now. And what'd you get again? Sam, is that right? It's definitely going to be positive, so be careful. Check your work.
I got 10.5 too.
Probably had a negative sign missing somewhere. Hey, folks, listen. You should not be using more than one line of command for this. Put it all in one line. But the common mistake in the other class, people forgot to close the parentheses after the degree. Okay, the common mistake in the other class. So negative 16 times sine 28, close the parentheses for the 28. Then plus 10, then plus 12 sine 42, close parentheses. All in one line. Lil, good?
You said we reset our calculator, it goes back to radian, so we said we have to do that.
We were doing plotting and math, so we cleared our calculators after we
So just go back and hit mode and go back to degree. Yep. Guys, every time you do something in trig, you should, before you even begin calculating, hit mode and check you're in degree. Okay, please do that. Because your answers in the test will make no sense. And the logic behind this will make no sense either if you do it the wrong way.
What is radian?
It's another, you know how units are like centimeters versus inches? Radian and degree are just different units. So they are. It's a measurement of angle. A measurement of angle. You haven't learned about it yet. You'll learn about it this year. Yeah. Okay? All right, now, this is what we know. What does that mean to me? Here's what this means. Ready? This means that as the ant going for that piece of food, I'm going to go 23 centimeters this way, because it's negative, right? Left. Then the y direction is positive. So which way am I going to move next? Up. And take a look at my diagram. Doesn't that make sense? Follow my cursor on here as it goes from beginning to end. I go left, and then I go up. This indicates left. This indicates up. Remember, this is in the x direction, and it's negative, which means go left. This is in the y direction, and it's positive. That means go up. So let me draw the triangle, please. Give me a moment. There's the triangle of motion. Negative 23.04 is the base of the triangle. 10.5 is the height of the triangle. Your goal is to find the hypotenuse. Okay, hypotenuse. Go ahead and figure out what that hypotenuse is. You should be able to do it on your own by now. You know the legs of a triangle. How do you find the hypotenuse? Use that theorem that you know. Remember, this base length here is 23.04. This is 10.5. You do not need to include the negative sign when you do this because you're going to square it anyway, which makes it a positive anyhow. So please, just don't even use the negative sign here. You don't need it. You don't need the negative sign at all, besides it tells you that you're going west. Okay, Lil, what do you got? No, it's not 20.5. Guys, you can't get a hypotenuse that's smaller than a leg of your triangle. Please, come on, common sense. The legs are 23 and 10. How could the hypotenuse be shorter than 23? Right? It can't. It's got to be more than 23. Chris? 25.3? Check your negatives. If you guys use the negative, it could be a mistake.
Of course you did.
Any questions on it? Was everything clear? No, should I have given partial credit to anything else? Thank you. See you after school. You okay? Okay? Yes? No, because we don't know the angles. You cannot use SOHCAHTOA here yet because we don't know the angles. Okay? That is the displacement. Now, we also need to know the angle. Remember, where is the starting point? Where is the starting point in this diagram? Tell me that. Bottom right, top left, bottom right, or bottom left? Bottom right. Yeah, bottom right or southeast, down here. So here's my starting point, right? So if I think about this, and I want to figure out what the angle is for my final vector, it's 25.3 at some angle, I recognize that from here, that's the vector that I'm going to move if I were the ant. If I were the ant, instead of doing this, I should have just done this to get directly to that piece of food. So I want the angle between the vector and the horizontal. Since the horizontal is this line right here, because that's the starting point, and that's the vector, I'm looking for that angle. Which again, tells me I could use opposite over adjacent always. It's always going to work this way. Always, always, always. So let's go ahead and do that. We could say the tangent of theta. Remember, this is theta right here. There's theta. That little angle I just drew in between the blue base and the red hypotenuse. That's theta. Tangent of theta equals, opposite is the y value over adjacent, the x value. Remember, guys, it's geometry. So the negative sign is not being utilized here. Please don't use it. The negative sign is only going to help me know that this ant traveled west and not east. If it was positive, it would be traveling east. Okay, so the 23.04, you do not include the negative sign. You do not. So remember just to use either the absolute value or just remember to drop the negative sign. How do I get theta, though? How do I get theta? How do I get rid of tangent? What function do I use to get rid of tangent, Tom?
It would be equals tangent -1.
Inverse tangent.
Good. And that's the word we want to use. She's right.
10.5
So tangent inverse of, not times, of, because it's a function, like f of x, tangent inverse of a function. Tangent inverse of the quotient 10.5 over 23.04.
Equals 24.5.
24.5? That sounds reasonable. That sounds reasonable. If I had gotten something like 80 degrees, probably not very reasonable based on my geometry here. If I'd gotten a negative answer, I probably forgot to get rid of the negative 23.04 and make it positive 23.04. So what'd you say again?
24.5.
24.5. So let's summarize our answer now.
So why can't you only use opposite and adjacent? Why can't you use the hypotenuse?
You can, but the opposite and adjacent will always work, so why not always use it? Just get used to it. It's always, guys, have you picked up on the pattern? It's always going to be tan inverse of y over x. This was y, and this was x. That will always work. So don't make it complicated for yourself. I could do this whole problem without even drawing the diagram, because I remember to break up my x components, break up my y's, use Pythagorean theorem to solve for the r, and then use tan inverse of y over x. I don't even need the diagram. So use tan inverse of y over x to be consistent every time.
Always,
You
on
could-
every single problem.
But you could, on any of these vector problems, if you want to determine the angle, tan inverse is the way to go. Okay?
What do you say when they throw in like magnitude? What does that mean?
Magnitude is the number, direction is the angle. So we already got the magnitude. What's the magnitude?
You add them together? 24.5.
No, that's the angle.
Oh, it's 23 point.
What was it?
25.3.
25.3. What was the hypotenuse? Wasn't it 25.3? That's the magnitude.
And then angle, I got you.
Is it going to be what direction? What's up and left? What direction is that?
Northwest.
Northwest.
What's the R? What's it?
The resultant equals 25.3 centimeters at an angle of 24.5 degrees northwest. Okay, so this little bug that was crawling could have taken a direct path for that long at that bearing or that angle. Okay, to accomplish the same task as he or she accomplished by doing this. Okay, that was the direction. Instead, it could have just done this. That exact route. Time.
How do you get 25.3?
Remember a squared plus b, the hypotenuse of the triangle up above?
Yeah.
That's what that is. Remember, this, guys, this right here is always going to be the hypotenuse if this were the triangle legs. Okay? So again, this is the hypotenuse of a triangle with this as a height and this as the base. A squared plus b squared, or x squared plus y squared equals r squared. That's how you get r. And then to get the angle, do the tangent inverse of y over x right here. Over the weekend, what I want you to do is practice the homework questions. Okay, practice the homework questions. Some of them aren't even as difficult as this. I think one of them even says, what is the horizontal component of a plane's velocity if it's taking off? All you got to do is the velocity times cosine theta, the horizontal component. If you want the vertical component, the velocity times sine of theta.
I was gonna say there was one more. I think it was like there was a plane one, but it was a little different. It was like how fast should a car be if you're like
The question was, how fast should a car on the ground travel so that it goes the same speed as a plane or keeps up with it and paces with it? So you want to find the horizontal component of velocity. Think about a car here and a plane, right? Plane takes off. For these to move together, the horizontal component of the plane's velocity has to match the car. So if you can find the horizontal component of the plane's velocity, that's what the car's velocity should be. Because this is all horizontal, isn't it? So for them to move together, this has to move really fast. Say this moves at like 500 miles an hour.
So that's just
This
one
might only
step.
be like 200 miles an hour. But the horizontal component of this would be 200 miles an
That's
hour.
just one step. It's like half of that.
Mm-hmm.
Gotcha.
Okay, let's go on to section 3-3.